The basic laws of physics, things like F equals ma, gravity is inversely proportional to the distance squared, Schrodinger's equation, and so on, don't say anything about the direction of time. Sure, they relate what's going on now to what happens next and to what happened previously, but there's no distinction between forwards and backwards in time. The past and future are on an equal footing as far as the microscopic laws of physics are concerned. In the macroscopic world, however, there is one rule that does have time going in one direction only, the second law of thermodynamics. That says that any isolated system will tend towards increasing entropy or disorder, like how cold milk and hot coffee mix together into lukewarm coffee milk, but will never unmix from each other. Once a system gets to its fully disordered state, its equilibrium, there's no more direction of increasing entropy to determine the arrow of time. So the fact that we experience the flow of time right now means that we're not in equilibrium. There are basically two ways that could happen. Either the universe just happens to be right now in this particular low entropy configuration with two directions of time flowing out forward and backward from now with increasing entropy in both directions, or at some point in the far distant past, the universe started with even lower entropy and disorder has been increasing ever since. Spoiler alert, it's option number 2. That low entropy configuration was the Big Bang. 13.8 billion years ago, the universe was hot, dense, smooth, and rapidly expanding. A smooth, dense plasma of particles might not seem organized and low entropy, but when the density of matter is extremely high, the gravitational force between particles is enormous. Smoothness in the face of such tendencies is not equilibrium, but is actually a very delicately balanced low entropy state. Things want to be gravitationally clumped together into concentrated configurations like protostars, proto-galaxies, or even black holes. What would a high entropy equilibrium universe look like? It would be empty space. And indeed, that's where we're headed. The universe is expanding and diluting, and eventually all of the stars will burn out and black holes will evaporate and we'll be left with nothing but emptiness in every direction. At that point, time's arrow will have disappeared, and nothing like life or consciousness will be possible. The fact that our sky is decorated with billions of stars and galaxies, and our biosphere is teeming with life, is a reflection of our low entropy beginnings. We don't know why the universe started in such an orderly initial state, but we should be glad it did. It gave us the non-equilibrium starting point that's necessary for the flow of time as we know it to exist. Everything that followed, from the formation of stars and galaxies to the origin of life, has been a story of increasing entropy. Time's arrow isn't a deep feature of the most fundamental laws of physics. It owes its existence to the specific initial conditions of our universe.